Okay, we're moving on with 17.2, Law of Signs. We already did one day of law of signs. Today we're going to look at the ambiguous case, meaning that you can have one, two, or no triangles at all based on the information that's provided to you. So I posted two shorter videos on Google Classroom that I want you to make sure you watch before you watch these notes. Those two videos give you a good visual of how you could possibly get a triangle, or maybe you possibly cannot based on the given information. And then from there, it talks about how you can determine what that third side is. So we're going to do 3 examples. I'm going to just go quickly over what was shown in those videos, and then we'll just do 3 examples. So here, I remind you that you can have an ambiguous case. You have 2 sides given to you at an angle that's not included. So you could have 0, you could have 1, or 2 triangles when you're given 2 sides and an included angle. That should be a non-included angle. Let's go ahead and add that. That was a typo. Okay, 2 sides and a non-included angle. Read that as side-side angle. Don't read it the other way. Say angle side-side. It is the same thing, but usually see it as side-side angle. So what you want to do is check to see if you can actually construct a triangle with that information. So you're asking yourself, is the given side larger than the height of the triangle? So looking at this example, you can see that you have a side given here, a side given here, and an angle. So you're looking at that angle, that side opposite that angle, and asking yourself, is that bigger than the height? If it is, then we can get a triangle. So the answer would be yes. You can get a triangle. It can be constructed from that. If it's exactly the same. If it's exactly the same, then it's going to be a right triangle. So if I'm going to call that side opposite the acute angle, let's call it A since we used A down here. So if A is equal to H, then you have a right triangle. Okay? But if it is not equal, if it's not larger to it, then there is no triangle because it's going to look something like this. It's too small, you bring it down, you can't get a triangle. So again, 3 things that you need to look at. You're comparing the height. If the height's exactly the same, you get one triangle, and it's a right triangle. If it is smaller than it, then you get no triangle. And for this one, we're talking about an acute. No triangle if it is smaller. If it's an obtuse, you have to compare that as well. But let's finish with this one here. Once you see the angle being between the value for B and the value for H, you can either have 2 possible triangles here, depending on which side you swing it. You can swing it over here, or you can swing it over here, and you can see you have 2 triangles. So there's that ambiguous case that we're talking about. Okay. If A is greater than B, if it's bigger than this side, then it can't swing in, it's got to swing out, and so that's when you have just 1 triangle. Now, when we talk about an obtuse triangle, if that angle is a right angle or an obtuse angle, you still have to do the comparisons. If it's a right angle, you can compare it and see if it's equal to it. If it's equal to that side, it would just swing right down on top of that right angle, so you would not have a triangle. Also, if it's less than, it wouldn't reach over to give you a triangle at all. So if A is bigger than B, then you can see that you can get a triangle from that. And again, watch those 2 videos because they give you a really good visual of that. Just to recap that really quick, remember if this side opposite the given angle is smaller than the height, it's too short, it will not give you a triangle. If it's exactly the same as the height, it is the height, and it gives you a right triangle. If it's greater than the the other given side, then it's going to give you 1 triangle. And if it's somewhere in between the height and the value for B, then it's going to give you possibly 2 triangles. So that's our ambiguous case. So let's do 3 examples. Let's start with this first one up here. This one says you have a triangle and you're given angle B and you're given the side A and the side B. So I'm going to go ahead and sketch that. And you can sketch it on your paper. Here's my triangle that I just drew. It tells me angle B is 29. The side opposite of that is 12. I drew angle C up here and angle A here. And the side opposite A is 29. So what I need to do is I'm comparing this side to this height. Now we see that we have a acute angle that's given. So I'm going to compare this to the height. If it's equal to the height, then we can get a triangle. And it'll be a right triangle. If it's smaller than the height, we don't get a triangle. So let's compare that. And how do we get that height? Well, you're just looking at this triangle right here. You're looking at B at 29 degrees. You're looking at C, and you're looking at 29 here. And I'm going to call this H for the height. So if I'm looking for that, and we know this is a right triangle, we can use sine, opposite hypotenuse. So we're going to do the sine of 29 degrees is equal to H over 29, and multiply 29 by both of those, and you get 14.1 equals X, or H is what I called it. So let me fix that. Compare the value here for B, and I compare it to the height. How does B compare to the height? Well, B is 12, our height is 14.1, and it is less than that. So that means I really can't even get a triangle, because if I swing that down, it's not going to come all the way down. It's going to stop about right here. So this is not a triangle. It's not a triangle because 12 is less than the height of 14.1. So understanding that the hypotenuse of this right triangle right here is smaller than this here. So just to see that one more time, this is 12, this is 14.1. You know that that is not possible to have a triangle like that. This is not okay. All right, so we're going to do this one. I want you to go ahead and draw it on your paper, and I will, so pause the video, draw it. Your triangle looks something like this. Notice it's an obtuse triangle, and I want you to see if we have a right triangle there. So we're going to have an obtuse triangle. We don't have to find the height on that. We can just compare the sides. So I notice right away that I have a triangle that has two sides that are exactly the same. Can I get a triangle like that with two sides that are exactly the same? I could, but is it going to give me what I want? So there's to be an isosceles triangle, if this is something that's possible. So I'm going to draw it a little bit different. It doesn't have to be drawn to scale. This is just a sketch, because I'm looking at 34 here and 34 here. So if that's the case, I'm going to draw it. So I drew it so it's not to scale, but I wanted to emphasize that we're saying these two sides are the same, so these two angles are the same. Could I have an angle here that's 126, right? And could I have this angle also 126? Is that even possible? It's not possible. So this one is not a triangle. Let's look at one more. All right, so looking at this one, it says find the measure, we're going to find the measure angle C. So we first need to draw it and see, can we get a triangle at all? My triangle ABC, and I drew it for 83 degrees here, and opposite that is the 25 miles. Drew angle C here, and opposite that is 13 miles. Now I need to see, is this a triangle? So draw in your altitude, and like that altitude or that height, and what you're doing is you're comparing this 25 to it, or this 13. Okay, either one. This has to be bigger than this. This has to be bigger than this. So let's compare that. I'm going to call this x. And we talked about how we find this. We use sine. So the sine of 83 equals x over 13. Multiply both sides by 13. And when you do, you get about 12.9 is equal to x. So how does that compare? How does this 25 compare to this x? 25 is greater than 12.9. So because it's greater than 12.9, yes, we can get a triangle. That's the first part. So we first checked, can we get a triangle? The second step is, are we going to get one or two triangles? And so that's where we have to compare the two sides. So how does this 25 compare to this? 25, is it greater than 13? If it is, then we get one triangle. It is. It's greater than 13. And what that means is that we can't take this 25 and swing it this direction. It has to be out here. It's like this example up here. Depending on what your value for A is, how does it compare with this B? If it's bigger than B, then it's only going to swing out like this. But if it's between the size of the height and B, then it can swing this way or it can swing this way, so you can have two possible ones. And the one we just did gives us this one here. So let's go ahead and finish this problem. This is going to give us one triangle. So let's go ahead and find that one triangle. So our third step is to look at this, and since we know that this does give us a triangle, we can go ahead and use the law of sines. Okay, so sine of 83 degrees over 25 is equal to the sine of C over 13. So we're just going to cross multiply. We get 13 times the sine of 83 equals the sine of C. And actually, I'm not going to do the cross product property. I'm just going to multiply both sides by 13. So that way I already have the sine C isolated. Since we're looking for the measure of an angle, we're going to use the inverse ratio. So the inverse sine of all of that gives me the measure of angle C. And so all of this goes in here. 13 sine of 83 degrees divided by 25. So you put that in your calculator. And when I put that in my calculator, I get the measure of angle C is about 31.1 degrees. All right, I'm going to pull out the notes from the other day. We're going to do that one problem that we skipped in our notes. Okay, so this was the problem that we had on our notes yesterday that we skipped. And that was one where we were asked to solve for a triangle side-side angle. I'm not going to do this whole solving for the triangle on our notes today, but I am going to say let's find the measure, or let's find the, find the measure of angle C. So we'll find this angle here. So go ahead and sketch that picture down on your paper. Pause the video if you need to. I'm going to copy it over on our page of notes that say that's given to you and you're not really sure if it's a triangle because you see the side-side angle. You see the angle's not included. So you want to find out, do we have a triangle? So to find out if you have a triangle, the first thing again you want to do is make sure that you draw in an altitude. So I'm going to draw that altitude here, or that height. And I want to figure out how this side compares to here. How does it compare? Is it the same? Is it greater? How does this side here compare? How does A compare? So let's figure out what this is. Let's do sine of 41 degrees equals the height, so opposite over hypotenuse, over 18. And when you multiply both sides by 18, you're going to get 18 or 11.8. So the height is equal to 11.8. So as we look at this triangle, it makes sense because when I look at this triangle, I can see that this hypotenuse of this right triangle is bigger than this other leg, which makes sense. So because of that, the answer is yes, we have a triangle. And I need to know that because if I don't have a triangle, there's no sense in trying to find the measure angle C. So now we can find the measure angle C by using law of sines. So sine of 41 over 28 equals sine of C over 18. So we'll multiply both sides by 18. And we'll take the inverse sine of all of that, and that's going to give us the measure angle C. So put that in your calculator and see what you get. We're going to do the same thing. Inverse sine of 18 times sine of 41 divided by 28. I'm going to get 24.9. 24.9 degrees. Could have got the same answer. So that gives you 3 examples. Let me see if I can find one more to add to this. Here's the last one we're going to do. It's one that I think is going to show you the possibility of having 2 cases. So here we have, given the measure angle A is 32, B is 12 centimeters, A is 8 centimeters, find the measure angle B. So I'm going to go ahead and sketch what this could look like. Okay, so it's an acute angle. I'm going to say this is 32 degrees. I'm going to call this angle A. I'm going to draw across from that 8 centimeters. And I'm going to have angle B here. And over here, I'm going to have 12 across from B. So that's what my picture is going to look like. The first question I have to ask myself is it a triangle? Because I'm not given the picture, I'm given the information. So I have to see. I have angle side side, so it may or may not give me a triangle. So I'm going to draw in my height. And I'm going to use sine to figure out what the height is. So sine of 32 equals h over 12. When I multiply both sides by 12, I get 12 times sine of 32 degrees, which when I put in my calculator, I get 6.36 is the height. Again, we want to compare that. We know that in this case, 8 is less than 12, which is okay. We want it to be that way. So we noticed in the beginning that 8 is less than 12. So how does it compare to the height? So if I look at the height, remember if A is between the height and between B, B is 12. And if we compare, let's not put the number in yet. So if we compare the height and B, if this is the case, then we can get 2 triangles because that side's gonna swing, okay? But if we get A is greater than B, then we get 1 triangle. So is this one of the cases? That's what we're trying to figure out. So our B is 12. And so if we look at it in this case, our height is 6.36. Our value for A is 8. And our value for B is 12. That's true. If I looked at it here, our value for A, we already said, was 8. And our value for B was 12. And so this was okay, so we knew we can get, a triangle. But can we get 2 triangles? And in this case, we are. This means that we're going to get 2 triangles. because we can have that side swinging in or away. So we're going to look at two possible cases because we can have two triangles. So let's do case 1. I like to say case 1 and case 2. So case 1, looking at the original figure. So we're going to use that original figure that I drew with the side pushed away. So that original figure, it looks like this. 8 is here, 12 is here, 32 degrees is here. And we're just going to use law of sines to figure out angle C. So sine of 32 degrees over the opposite side 8 is equal to the sine of C over the opposite side 12. Calculate that, and we get 12 times sine of 32 over 8. You're going to take the inverse sine of that to get the measure of the angle. And when you put that in your calculator, calculating the inverse sine, we are going to get, if we round it to the nearest whole degree, let's write that up here, round to nearest degree. Let's say that was part of the instructions. We would get the measure angle C is about 53 degrees, because this gives me 52.6. So about 53 degrees, if we look at it that way. Second case, case 2. Case 2 says, instead of that angle being drawn out here, it's going to be pushed in here. So we'll keep that first 32 degrees looking the same. But instead of having it go out like this, we're going to bring it in like this. You can see the difference between those two. We're going to call this 8 still, this 12, and now we're going to still find the measure angle C. As we look at that, it's going to be a little bit different because we can figure out what that angle is. What I want you to remember is that we found the measure of angle C to be 53 degrees. And that was with it drawn this way. So right here, if this was 8 out here, we left that original figure, this angle right here would be 53 degrees. Well, notice that by pushing it in, we've created an isosceles triangle right here. So if this would be 53 degrees, then this would be 53 degrees, leaving us with this angle being 127 degrees. Finding the second case is a lot easier to find the measure of that angle. So what this is telling us is that then the measure of angle C can equal 127. So hopefully that makes sense as we drew that up there. Remember, the original case looked like this. And I said, all we're going to do is we're going to take this piece here and swing it in so it looks like this. And so this was 8 out here, it's 8 in here. That's how I got, knowing that from the original problem we said this was 53. Kind of going through this one more time in case you didn't get it. This here is an isosceles triangle, so if this is 53, this is 53. These are a linear pair. You have to remember from geometry, linear pairs are supplementary. So I took 180, subtracted 53, and that's how I got 127 degrees for angle C. All right, that's it. Remember, when you're checking these where you have side-side angle, you need to make sure you have a triangle. In order to do that, you need to compare the height to that side that's opposite angle A. All right, we're done. Good luck. Go back and review if you have to as you're doing this assignment. Don't race through it, and make sure that you check the odd answers in the back of the book.